Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, we'll be preparing to add more of the syscalls as C functions. So I'm thinking of implementing errno, well, the error number, so that if the syscalls fail, there will be a way for the user to know instead of just the syscall function returning a negative number. So let us get started. So let's add in the include folder and errno header and add the default header guards. Just call it errno h and comment this out. Now first, this will have the external integer called errno. Then over here at the source, um, let's set errno over here and errno, let's see where this is where errno lives. So include that. So if errno is equal to 0. And then for our syscalls over here, well, this isn't really how the normal libc does it. You cannot see this implementation. So let's move this into source. Over here, I guess. So copy this and paste that over here. And then what the syscall will have here at the include is where we'll have the syscall numbers, such as sys read being, was it 1? So 1L, and then sys write being now 2. Wait, I'm not good at converting to hexadecimal on the spot. So, well, read should be 0 and write should be 1. Oops. Well, let's check it out in the syscall tables for x86-64. So, read and write is 0 and 1. Then exit is 60. Now for the syscall over here, let's just call that internal syscall. So this will interfere with the syscall over here. So let's rename that. Uh-oh. Wait a second. Oh, there you go. I thought I lost it. Well, almost. Thank God for undos. And then over here at the syscalls function, we better include internal syscall instead. And then at the standard library, we'll be implementing this syscall where it's a C function instead, which would require, what would it require? Yes, the standard arg header for the variadic macros. We can try to implement this ourselves, but reading through the system VAVI for this is a pain. So we can just use the compiler's built-in VA functions. So VA start for this is, what's it called? Built-in VA start. Then the VA argument, then the actual argument before the last, well, before the ellipsis anyways. Then VA arg, this will take VA end type. So VA arg, then VA end will just take V. Also VA copy. So the destination then the source, I think. Now we have the main ones. Now we just need the type def or the built-in um, VA list. So that will be VA list. Oh, should it be like this? Okay. Now that we have that, let us declare in the Unix standard for the syscall. That would actually just take a syscall number and the variadic arguments. So how can we do this? Well, first I gotta rename the macro over here to have an underscore that might interfere later on. And then uh where was I? Then this is called, well, this should be internal syscall over here as well. And here this should be the underscore version. Now for this one, we need internal syscall, the Unix standard header, and then the standard arg header. So what can we do about this? So the long syscall over here, and then our return value. So we can just return syscall with number, but well, we still need the arguments. So let's declare VA list, then VA. Now we have SCAA over here. then up to 6 arguments. So the compiler will optimize away any arguments over here that is not really passed to syscall. But that's what I would like to believe. So 6 arguments, then we can start. Um, V with number, well, VA, then end that before returning. Huh. Oh, I just copied and pasted that. So this should be VAN. And then A will get VAR with the type of SCA. Well, B, C, D, E, and F as well. Now we can just add that here and F. Well, that is surprising. I guess I messed this one up. So I guess I gotta add another one over here. Then add 6 over here. And let's see how this would go. So is this now correct? Yes, it is. Then, well, maybe I'm still missing something. Since this syscalls, they can return a negative value. So let's add that. Something like syscall return with just one function. Um, a long value, then syscall return with the argument of, well, what this syscall actually return. So just ret. And then how should we go about this since there's also errno to think about? It's not like the syscall that we have will set the errno for us since we're the one implementing it. So we gotta search it up what errno is. So errno numbers for Linux. Well, I see here in the gist. So up to how many are these? Surprisingly, up to 132. But, well, if there are any, so how should we go about this since there's return? And how should we compare this so that if it succeeds, the actual syscall after this will return -1, else it will just return the value that the syscall returns. So how can we distinguish that? Well, let's consult glibc. So right over here in glibc, it will return -1 on failure, though I believe this is a work of something like syscall return. returning -1 after setting errno to something. Though maybe if return is just less than 0 then, though I believe this will mess something up later on. But let's see. Also over here, let us declare syscall return so that we have something to rely on. And the actual syscall macro will call on syscall return with these arguments. So over here, well, that should be now right. And let's try building this. Oh, I did not add these to the headers. So add um, stdarg and then errno .h. Then what else? Okay, these are the 5. Now over here in libc, we should also add another source folder. We see files just inside the source folder. So let's rerun this. And oh, errno cannot be used when making a shared object. Compile with the position independent code feature. Alright, I actually forgot about that. So maybe I should add a feature in the beta that if it's a shared library, it will automatically add the FPIC version of this argument for their specific build tool. Huh. Oh well. So let's rebuild that and see what would happen. Now it's trying to find stack check fail. So I guess it's trying to use a canary to check for the strings being clobbered. So we can add that maybe in a miscellaneous implementation. But we can also move this here. This will mess up these over the. So miscellaneous over here as well. I feel like I'm forgetting something. And it's not just this once. I feel like I'm forgetting something else. Let's read the errno man page. Uh-oh. Uh, well, that's cool. On other functions, -1 is a valid return on success. So on our return will be wrong if that's the case. So let's try -1 instead. And then what else? Nice, we can try this out now. The running build. Oh, where is this one? I don't think I forgot it on the actual syscall implementation. Now we can add stack check fail. So for now, I believe we can just exit out of this. So call on the standard libraries, exit one. We gotta add the macros for that, for the exit statuses later on. Then write out to the standard output that, well, stack check failed. Wait, how does it do that? I forgot the message for stack check failed. Let's see. Oh, well, there was more. It seems like there's more to this. But well, not my problem right now. So I believe this is 19 characters. And let's see if it will make GCC happy. Okay. Now here in main, let's return errno. And see what would happen. So let's run this. So I guess it's still returning 0, and that's fine. It's not setting errno since write did not fail. So, well, it's a bit longer than the usual unstd-c videos, but we did implement a few more things over here. But instead of write, I wonder if we call on our custom syscall function, what would happen? Just to check if this works. Okay, that's a problem. Since, well, we actually need the syscall number first, then the file descriptor, or the arguments for the syscall. Now let's see that. Okay, now it works. So the syscall function now works along with the macro version and with the variadic arguments as well. So maybe I can just implement the other stuff here off camera, since it will just be like this. No, more like this. So thank you for sticking with me this far, and may I see you on the next one.